So here is where we ended yesterday with my mistakes in all their glory. But we have the right thing in the end. Now, the last part of this question says to interpret the meaning of your answer in the context of the problem. Okay, so we have this. Here's what they look for to when they're grading it. They're looking for a product, which means even if the numbers were easy and you could do all this in your head and you could actually come up with a number, which I don't want you to do because we don't want to make weird mistakes. If you don't show that there's a product and you don't show that there's a sum, then you don't get those points, right? So this is way better than even if you just knew what the answer was. So we want to actually show the multiplication like we're doing. We want to show the addition and so forth and have your units and all that stuff. But then we also need to interpret it. Okay, so we got however many gallons, right? And so I'm going to go back and reread the question. And it says water is flowing into the tank over a 12-hour period. So that makes me think, this is gallons of water, right? The rate at which the water is flowing into the tank at various times is measured, and the results are given in the table below. And blah, blah, blah. The tank contains 150 gallons. Use left Riemann sums with 3 subintervals. Does not say equal. Pay attention to that. To estimate the area under the curve. So it just says to estimate the area. Well, we've estimated the area, right? And now, aren't you used to as a geometry teacher for years, I said it too, and I might have even said it in context that wasn't geometry, but anytime you find area, your units are squared, right? If I'm going to find the area of a square and it's meters by meters, it's meters squared, right? Area is meters squared, volume is meters cubed. That's just the way it works, right? We found area. Is this gallons squared? No. But the reason we used to, you used to have heard it's always squared is because if we're finding area of figures and it's not in a real world context, you're multiplying 2 units together and the units are always the same that way. This way the units are not the same and they cancel out, so it's not gallons squared. But it's still area, okay? Think about when we took derivatives, right? So let's say that we had something. What is a derivative? What does it give you? Slope, okay? And another way to say slope is change, the rate of change, right? Y'all agree with that? So if we're talking about, we're driving somewhere and I'm going to go however many miles, okay? My trip was this amount of time. I went this amount of miles. When we take the derivative, it's our instantaneous rate of change, right? That'll give me my miles per hour right there. This, we're going backwards. Instead of getting gallons per hour, we're taking gallons per hour and changing it back into gallons. We're going backwards. Does that make sense? We're undoing our derivatives, right? But we still have to be able to state things correctly. So this is gallons, and we assume from our question, obviously it's going to be gallons of water, right? So this, we can interpret this and say, this is the amount of water It's a little easier to write that than to try and make that fit in a sentence, right? It's just going, we already have it. There it is. This is the amount of water. Now, is this the amount of water at any given time, like instantaneous rate of change? Did this tell us that? What is this water? Is it at a specific time or what? What was our interval? We went from 0 to 12. So it's all of this, right? So can you tell me from what we have how much water was in the tank at 5 hours in? We don't know that, right? We know the rate, but we don't know how much. So it's not even though the derivative can give us the instantaneous rate of change, this isn't giving me an instantaneous measurement of something. This is an accumulation. It's like I can fill it in. We're accumulating area. It's an accumulation. So it's the amount of water, not that's in the tank, but that flowed in, came in, however you want to write it. But since it says flowing, I'm going to say flowed. That flowed into the tank. Now, we found this over an interval, so our answer in our description has to talk about an interval. We can literally write it as an interval, or you can say that it flowed into the tank from t equals 0 hours to t equals 12 hours. Okay? So it's important not only that we can do the math, but that we can interpret what the heck we just found. Okay? And I don't have that exact number to know what it is, but it's really kind of irrelevant. That many gallons is what flowed into the tank from t equals 0 hours to t equals 12 hours. We okay with that? Make sure we have units here. Make sure we have units here. Oh, this is okay, is it the exact amount? No, what is it? Approximate. So we're going to add that in there. Approximate amount. So if we're actually adding up the numbers like this with the rectangles, we are approximating. We're going to be able to find the exact. That's why on the front, when we approximated it, I was able to give you a number, because if we actually do the calculus behind it, you can get the exact amount. Okay? Everybody okay with that? We good? Questions? Okay, good deal. All right, grab your other piece of paper. Oh, I did have that one printed out. Look at that. Okay, so whatever page it was, help me out here, 57 again? Alrighty, so we have these beautiful graphs. So approximations are nice to have, right? But the early calculus pioneers wanted exact values. Probably not just them, other people wanted them, they just didn't know how to get them. To do this, they employed more and more rectangles, which generally improved the approximation. So if you look at this, well, first of all, are these left-handed or right-handed rectangles? Left, because that's where we start, right? The left-hand side is the y value. You start at the left, you draw to the right. Okay, so these are left-hand rectangles where they have 1, 2, 4, probably 8. I don't know, I didn't count them. Of these 4, which one is the best approximation? The last one, right? Because it has more rectangles, so you're losing more and more of that white space and getting closer and closer to it. So if we did 16, it'd be even more, right? If we just keep making them skinnier and skinnier and skinnier, we'll get closer and closer and closer. You know what? I knew there was a reason I should have bought it. Y'all know those little toy things that look like a bunch of little nails you can like put your hand in or like press your face in it? And I saw one of those the other day, and I was like, I totally don't need this, but like my parents never bought me one. It was one of those things where like, I want one of these things. But that's kind of what I want you to think about. Think about taking those little pegs and you're trying to put them up underneath here so that it fits in there and makes that curve. You with me on that? Okay, so see, I could have shown you. It could have been now I'm going to have to find one of those things. So ideally, don't you want them to be, like, what do you think you want the width of the rectangle to be? Super, super small. Like, how could you word it? Like, infinitely small, right? Infinitely small, almost where like it's so skinny you can't even see it, right? Which we can't, it's hard to comprehend, and I definitely can't draw. So it says, if more rectangles produce better approximations than infinite rectangles, infinite rectangles produce the exact value. Now, we could find the area of 8. We could find the area of 16. We could find the area of 5 million. It would take us a while, but we could do it. We can't actually literally calculate, doing the same process, infinite amount of them, right? Because we can't even draw that many. So that's where the calculus comes in. Okay, so our connecting Riemann sums to calculus. So here's our Riemann sum, which is something that you will be required to do on the AP test. So even though we're going to find the exact way to do it, that approximation is still something important. It's not like we just look at it to make the connection. That's something that we still have to be able to do. So our number of rectangles is in this case it's 3. We find the area of each rectangle. So notice that it's f of x times delta x. So that's your y value. So this is your y value times the change in x, which is your, I guess, your width of interval. Right? So it's like the base times, and then that's your height there. So the total area, do y'all remember what this Greek letter is called? Sigma. Oh yeah, that one's delta. This is sigma, right? So sigma, what does sigma mean you do? Sum it all up, right? So your total area is summing up in amount of rectangles, and then this was your area. You're summing up each area. Okay, does that make sense to you? That's what we're doing. Okay, so for our exact area with calculus, the number of rectangles is an infinite amount, like we just talked about. This is your change in x. Well, dx, when you do like dy dx, it's the change in y with respect to the change in x, right? Well, this is just the change in x. So instead of delta x, it's just your dx that comes from dy dx. So that looks almost identical there. And then your total area is just the sum of that. We are going to change the notation changes a little bit to this looking thing right here, which is literally called a long S. So we're going to do long S problems. Get it? Yeah. I know. Say it really fast. We're going from A to B. This gives us our interval, and this is just the area of the rectangle. Okay? And long S problems. So we will write that eventually to represent the true area found by using infinitely many rectangles. Okay? Still working on Riemann sums here. All right, I know. So funny here. All right. So let's look at this one. We're still approximating and interpreting. We're leading towards, we're getting to, anybody know what the process is called when you do the long S? Because y'all seem to know that a derivative was a thing. Integration, it's an integral. So you take the derivatives and you go in one direction, you take an integral and you go in the other direction, just undoing it. I know, it's like learning addition and learning subtraction. We're all good. Okay. So a department store opens at 9 a.m. and closes at 9 p.m. The rate that people enter in people per hour is modeled by this function. And notice that this is p prime of t because, again, the idea is we're going backwards, right? And when we multiply people per hour times hours, what are our units going to be? People. So when we find the area, I know you're like, then we're going to get people. Where t is the number of hours after 9 a.m. The table above contains values of p prime of t at selected values, selected times of t. We're going to use the data in the table to answer the following. All right, so it says use left Riemann sum, okay? 3 subintervals. Does it say equal? No. Could they still be? Yes. Should I make it do that? No. What should I pay attention to? My data, right? Should actually look at what I have. To approximate the area between p prime of t and the t-axis, which is your x-axis, from 0 to 5, okay? So I'm going from 0 to 5, and I need 3 subintervals, and that makes it very nice right here. 1, 2, 3. Okay. So, include units of measure. Now, when we do this, when I go from 0 to 2, the width of this interval is 2, right? From 2 to 4, what's the width of that interval? 2. From 4 to 5, what's the width of that interval? 1. Okay? Now, if we're doing left-hand rectangles, in my first interval here, which number is the height? 11, right? In this second interval here, if I'm doing left-hand rectangles, which one's the height? 30. In this interval, if I'm doing left-hand rectangles, what's my height? 54. So do I have to actually draw it and plot everything? No. If you need to and it helps you, not the end of the world, right? But we're going to find it. So we're going to say we're going to sum up. Okay, there's my sigma. That looks really bad, I know. And we're going to go from, we're going to sum up 3 rectangles. Okay. And then the way we find this is we're going to do p prime of t times delta t, the change in t. Right? Does that make sense? It's the y value times the change in the time, which is we already found it's 2, 2, and 1, right? It's not the t value, it is the change in t. That's one of the biggest mistakes that happens there, okay? Second biggest mistake is using the wrong number. So when we do this is going to be equal to, all right, so we know that we have little rectangles underneath there. The base of the first rectangle is what? 2, because it's the change. This is my base. It's 2. We multiply it by what? 11, because this is the left Riemann sum, so from here to here, I use the left. Plus, what's my next base length? 2, times what's my height? 30, plus my next base length? 1, times what's my height? 54. Notice with the 11, 30, and 54, I didn't skip over anything. You just have to know which one to start with on the first one, then you can just go down the line, okay? And then I have all three. Those are pretty easy numbers. I actually could multiply and add. Should I? No. I need my units. I think you should literally take your units, people per hour, multiply it by hours, and figure out what you get, okay? So that you don't do something weird. The units on this is people. Okay? Is this the exact number of people? No. It's the approximate number of people. All right, so then I can say this is the approximate number of people, and I can write that part. I haven't even gone back and reread the question to see what these people are doing yet. People, okay, what were these people doing? Blah, blah, blah. The rate at which people entered the store. Okay, the approximate number of people that entered the store Now, we could use t, or we could talk in actual terms of time. It says that it's the number of hours after 9 a.m. So, I mean, if you want to do the math with time, is that fun to do sometimes? No. I personally would not do that, just because I'd be afraid I'd count my time wrong, and I don't have to. So, but I can't say, you know, it's not 0 a.m. to 5 a.m. or anything like that. It is the approximate number of people that entered the store from t equals what? 0 what? Hours to t equals 5 hours. Okay? What questions do you have? See how that works? Yes, thank you for asking that so much, because that was one thing I was getting at and I didn't actually say that. So he was, like, instead of saying from, saying at. Okay, so the difference between from and at is an instant. So you're telling me that that's how many people entered at that exact time. And that's not what's happening. It's over an interval. So that's the word from. We're going from this to this. That gives you an interval because it's an accumulation thing. Does that make sense? It's a very good question, because at is a very important word in a lot of the questions we do. If we're finding instantaneous rate of change, that's my rate of change at t equals 10 or whatever it is. But this is over a period of time. Anytime you have an interval of something, whether it's written as an actual interval like this, or whether it's written from this to this, that is over a period of time and not instant. Okay, very good question. Anything else? Okay. So let's read this second part here. It says use a right Riemann sum with 3 subintervals. I'll scroll up and write in just a minute. To approximate the area between p prime of t and the t-axis from t equals 4 to 12. So when I'm going from 4 to 12, this is 1, 2, 3. I only have 3. I have starts from the right. but I still have to go from 4 to 12. Does that make sense to you? So I have to decide how I'm going to break that stuff up. I still have to start at 4. I just did 3 things and I didn't end up there, right? So I need to stretch out one. Which one would make probably the most sense to stretch out? 4 to 6. Now, do you absolutely have to do that? Not necessarily, because it didn't tell you what to do, did it? Did it say equal? It didn't say any of that, right? And so to me, for it to be more kind of spread out, it does make more sense to go from 4 to 6, 6 to 9, and 9 to 12. Make sense? So even though I drew that, I'm going to say, all right, never mind. I'm going to go from 4 to 6, from 6 to 9, which is what I have right there, and then from 9 to 12, because I still have to go from 4 to 12. And you're right, it does say right, and we need to pay attention to that, but I have to start at 4. Okay, we good with that? So then I'm going to look at the lengths here. So from this interval, from 4 to 6, what's that? 2. From 6 to 9, 3. And from 9 to 12, 3. Okay? Everybody okay with that? Okay. And if you chose differently, you would have a different answer, but it didn't specify what to do here exactly, and it didn't come out evenly. So as long as you can justify what you did, you're fine. All right, so, and it says write Riemann sums. So we're going to find the sum of these 3 subintervals, and it's p prime of t times the change in t. All right, so I want you to think about what we're doing here. All right, what's the width of the base length of the first rectangle? 2, right? 2. What is the height of the first rectangle? 21, because it is a right Riemann sum, right? So on this interval, the right-hand value is 21. So 2 times 21 plus, what's the next base length? 3. What's the height? 44. Plus, what's the next base length? 3, and what's the height? 0, okay? Which we know 3 times 0 is 0, but you don't put 0 there or you're not showing your multiplication. You with me? That's why I say over and over again, your first step is 0 work, you just substitute it in. I don't care how easy the numbers are. And then what are my units on this? People, good. All right, now you write out your explanation. All right, what questions do you have? Do y'all agree with that? Can I move on? Or just invest already? Okay. So now it says to approximate the value of, and you get this long S here, right? So, okay, so from 0 to 12, so I'm going to take the integral from 0 to 12 of p prime of t dt. That is equal to the sum of, well, it says we're going to use, so we're approximating, that's how we know we're not actually doing the calculus behind it, midpoint Riemann sum with 3 subintervals as indicated. So we're going to have 3 rectangles, and we're going to do p prime of t times delta t. Okay, that's what we're finding. So this is what we've been doing. This is the actual notation. This should actually be like, well, it does say we're approximating, so it's approximately. I don't know that that squiggly one actually matters that much, but all right, we okay with that? Now we're going to have to decide what our three intervals are because we need midpoint rectangles. So I got to be able to find the midpoint. Like I can't go from 2 to 5 and use that as one of my intervals because the midpoint is not 4. Does that make sense to you? Like we're going to have to make sure that this works. If I go from 0 to 4, then 2 is the midpoint of that. So we're okay, right? If I go from, can I go from 4 to 6? Yeah, I can go from 4 to 6, right? And then I can go from 6 to 12. Okay, so those work. So you might have to, like it works out nicely and evenly up here, but you might have to, you need to make sure you actually have those values in there, right? Okay, so what is the width of our first, or what's the base length of our first rectangle? 4, okay? So I'm going to put a 4, I guess, here. Running out of room here. Need more room up there. And what about for the second one? 2, because it's, remember, it's your change in t, so it's the 6 minus 4. And then what about this one? 6, okay? Everybody okay with how we came up with those numbers? Okay. All right, so we're going to go down here, and I'll just start back over here since I don't know, I'm probably running out of room because I write too big. So what is our first base length? 4. And then for that rectangle, what would the height be? 30. Good, because it is where the midpoint is. Very good. Plus, what's the width of the next one? 2. And the height would be 26. Very good. Plus, then 6 times what? 44. Okay. And what are the units? People. All right. Everybody okay with that? All right. So then write your explanation, which is almost identical to the rest, but hey, write it over and over again. Maybe we can make sure we get it right in the end. What questions do you have? And again, do your words have to be exactly like mine? No, and I think you know that, but you know, try and write it the simplest way, but your brain can work differently, and that's fine. All right, if you don't have any questions, then you can go ahead and get that put in your ISN, and your assignment, and it's done better than it was in the past, is in AB Classroom. So